Okay, welcome back to Lesson 5, Kinematic Equations. This video we're going to be going over example 2, and admittedly this example may take a little bit longer than the rest of the videos have. Alright, so let's jump right into it. This question says that a particle accelerates at 470 meters per second squared north for 810 milliseconds. If its final location is 123 meters south of its original location, determine its initial velocity. All right, well, I'm going to approach this question just the same as I approached the rest of the questions. I'm going to start out by sketching a short, quick little diagram. So a particle accelerating at 470 meters per second squared north. Okay, so we have a particle. This is our particle, and it's going to be accelerating north. So this is my north value. That's really all we have. Its final location ends up though being 123 meters south of its original location. So actually, this particle is going to end up somewhere down here. All right, and so we're going to have a displacement. So right here, displacement of negative 123 meters. Negative 123 meters. So it's accelerating this way. Acceleration is equal to 470 meters per second squared. And what else are we given? We're given a time. So this particle is really accelerating quite quickly. This is going to be some sort of like a elementary particle or something in a electrochamber. Our time for this whole situation is 810 milliseconds, so 0.810 seconds. Perfect. Let's create our chart of 5 things. So we have, what order did I do them in last time? VI, VF, probably displacement, acceleration, and time. I think that's the order I did it in last time. And these end up being equal to, well, VI, I don't think we know VI. VI, we don't know. Final velocity, we don't know. This is actually a weird problem. Often we'll get one of these two, but we can still solve it. Displacement, here we go. We have negative 123 meters. We have an acceleration of 470 meters per second squared. And so you see our northbound direction here, north, south. North is going to be our positive, south is going to be our negative. Okay, and time. Our time was 0.810 seconds. Okay, this is the most important step, I would say, of any of these kinematic problems. And if you're not getting these in, well, I would recommend that you always start with the same process. Okay. So from here, we have to choose a formula. Let me change my color. We're getting into some math now. All right, we're on magenta. What formula do we have that, well, what are we solving for? Initial velocity. So we want initial velocity. This one we don't care about. So we want to find the formula that excludes velocity final, that has these other ones. The formula that I find is this. Delta D is equal to VIT plus 1/2 AT squared. And we're trying to isolate for VI. So we have a little bit of rearrangement work ahead of us. First thing we want to do is we want to isolate this VI term. So we're going to have, we're going to subtract both sides. We're going to minus 1/2 AT squared. Over here we're going to subtract 1/2 AT squared, and we're going to end up with delta D minus 1/2 AT squared, because these cancel, right? Is equal to VI T. So we're almost there. Now we just have to get VI by itself. So we divide both sides by T. So then I'm gonna isolate the VI now. So VI is equal to delta D minus 1/2 AT squared over T. Now this will work. If you want to plug your numbers into here now, put your T into here, your A into here, delta D into here, T down here again, that will solve your problem. I personally like to clean it up a little bit and just make it look a little bit nicer. So all I'm going to do is I'm going to divide this T, essentially expand it into both terms. You can skip the step and jump straight to the answer if you prefer. But I like to make it in this form. VI is equal to delta D over T minus A, and this T is going to cancel this T, right? So this is going to be AT over 2. Because this 2 is in the denominator. This T gets canceled by this T, and this square term also gets canceled out. Okay, now let's plug some numbers into here. I'm going to jump up here. So we have VI is equal to negative 123 meters. Oops, I wanted 123 meters divided by the time of 0.810 seconds minus the acceleration, which is 470 meters per second squared, times our time again, which was 0.810 seconds, all divided by 2. If we plug that in, we get an initial velocity of negative 342 meters per second. Well, what does that mean? Negative 342 meters per second. Well, our north direction, we stated in this question, is positive. So this is negative 342 meters per second north. But if we just flip the direction around, this really comes out to be positive 342 meters per second south. All right, that's that.